All right, we are back. First video of the semester. Congratulations, people. You made it. Second semester. Wow. Second semester seniors, actually. Congratulations on that, too. Are you ready for it? I think you got to start no matter what. So I might as well get started here. Let's talk to it. We're looking at the Explorer on 3.2. This section, okay, this particular section, 3.2, is all about correlation. All right, we did a little introduction to correlation back first semester when we did that tongue twister lab. Okay, so now we're going to revisit it a little bit in this section. Okay, go a little bit more in depth with it. Let's see how it goes. All right, so here's our Explorer. I'm going to pause now, take a second to look at the graph. Okay, I guess there was no explanation to it. It's just a graph as I looked in my book. So we use the graph to answer the following question. Write a sentence to summarize the trend of the graph. All right, well, if you look at this graph, you're going to see countries with the lower GDP per capita have a higher percentage that cannot afford food, a percentage of people that cannot afford food. And the people in the countries with the higher GDP have a lower percentage. Okay, so I'm going to say something like that. Along those lines, you could, you can write it any way you want to. Countries with higher GDPs have lower percents of citizens cannot afford food. I mean, they don't have that, but it's a lower percentage. As we continue to look at this graph, all right, part B asks us to doesn't ask us to do anything. It says, does the U.S. follow the trend of the graph, or is the U.S. an exception? So, it's a great question. I would say that it doesn't follow the trend of the graph. Why? Because if you look at Australia has a lower GDP than us and a lower percentage. Based on the graph, we should have a lower percentage of citizens that cannot afford food. But in this case, we don't, or lower percentage than Australia, but we do not. Okay, so it seems like the U.S. is the exception in this case. Let's say, or appears to be. I just kind of gave my countries with lower have a high, or excuse me, countries with lower GDPs have lower percentages of people that cannot. Okay. Estimate the percentage of citizens who cannot afford food last year in the country that has a GDP of about 48,000. So let's look at around here. We want to say it's probably in this area here. Okay, if we follow the trend of the graph, not looking at the U.S., not taking that into account, okay, but looking at the trend of the graph, I would say that we're looking around in this area. Okay, notice how we're falling, kind of leveling off a little bit. So it's around, what is this? This is 20, so this is about 10. You can say anywhere from 5 to 10%. 1% of citizens, etc. So right now, what are we doing in this section? We're looking at trends. We're looking at trends and graphs. K-determinant variables are positively, negatively correlated. Like I said, it's all about correlation. Drinking my liqueur passion fruit today. It's my lunch beverage of choice. Passion fruit, particularly, for which X value should the equation of the trend line be used to make predictions, and how can we interpret a residual? So I'm going to let you read this about linear correlation. Go ahead. So we've talked about lines of best fit or best fit lines before. Like I said, we haven't necessarily talked about positive versus negative correlation. It says since the graph on the left has a trend that is going up as you look from left to right. Okay, if you looked at the pictures that were given, I didn't include them. it looks like they're trending up. Negative would be the data is going down. So from left to right, I'm going up the mountain. All right, from right to left, I'm going down the mountain. That's kind of how I think of it. All right, for each pair of variables, determine if you have a positive or negative correlation. So the number of customers a company has and the total revenue of the company. Well, if I have more customers, I'm going to have more revenue. So positive correlation. The number of hours of overtime worked and the number of hours spent with my family. Okay, well, if I work more overtime hours, the more I work overtime, the less time I'm going to be able to spend with my family. This would be considered a negative correlation. The cost of a car and the number of people willing to pay for it. Well, the more a car costs, the less likely people are going to want to pay for that car. Let's be realistic here. What's an expensive car? A Ferrari. That's like a really expensive one, right? A Ferrari, there's not that many people willing to pay for a Ferrari. Okay? The Ferrari's cost is up here, but the number of people willing to pay for it is all the way down here. That would be a negative correlation as well. See one of those in person. The number of hours a student spends on an ACT prep course and her score. Well, I mean, ideally, the more hours you spend on a prep course, the higher your score is going to be. Now, if I'm going to be totally honest with you, when I took a prep course, my score went down. And then it went back up again, but it did go down initially. So, more times than not, that is going to be a positive correlation. All right? Okay. Let's look at this example. And they provide the solution for us as well. So, yada, yada, yada. I want you to read that. All right, here we go. So there usually is a correlation between your arm span and height. Okay, the taller you are, the bigger, the longer your arms will be. Sometimes it's not the case. Obviously, they're supposed to be equal. I don't know if you knew that, but your arm span and your height are supposed to be the same. My arms are actually long. I think are longer than my height. Not to brag, but you see guys in the NBA who have huge wingspans, like a 7 foot something wingspan. They're only like 6'5", so it's not always going to be true. So to begin, we want to graph. So they want to ask us to graph the scatter plot. Okay. The most important thing is you got to decide which one's your x and y values. Okay. The dependent variable is height. I guess they're saying, the book says. I don't necessarily agree with that. It says, what does the book actually say? It says dependent variable is height. I don't know if I agree with that. You could say that the dependent variable is arm span, or is arm span as well. Your arm span depends on your height. That's kind of a disagreement with this book a little bit. But the most important part here, guys, is the fact that look, there's a positive trend. They also show this little jagged, a little squiggly like that. Remember, that means just skip a bunch of numbers. Okay, skip a bunch of numbers. All right. Now there's all this other work in there. So remember that red line, that is considered the line of best fit right here. This is the line of best fit. It says using Excel or a graphing calculator, we can find the equation of the trend line. All right. You can do that using your graphing calculator. I'm sure you can do that using Desmos as well. Okay. And maybe I'll show you that when we go live. Okay, I'm not gonna do that right now though. So anyway, they found the equation of our line of best fit here. Okay, to graph this line, we choose numbers value between and substitute that in the equation. Okay, we can use. Okay, so this is the important part. It says once the x's are established and the points are labeled, Oops, not my best video, huh? Predict the height of a person who has an arm span of 67 inches. Okay. So that's kind of how you know that they want you to use arm span as the independent variable, because you're predicting the height. If your arm span is 67 inches, so your height, they're saying now, is depending on your arm span. I don't necessarily agree with that, but we'll just go with it. All right. So height is 0.9 A plus 0.73 H. So then you would plug that 67 in for A, because A is the arm span, and then solve from there. All right. We're going to do this slide together, and then we're going to come back as a class, and I'm going to put you guys into some groups, and you're going to tackle this a little bit too. I don't always like these examples the book provides, but we're kind of stuck. We got to use them. I mean, it's the easiest way for you guys to take notes. So let's just go for it. So the double bar graph is represented here. It shows the unemployment rate and median weekly earnings based on the type of degree that is earned. Answer the questions. Okay. So describe the trend you see on the graph. Are there any exceptions to the general trend? Give examples if possible. Well, if you look here, the higher degree, it looks like the higher degrees have lower unemployment rates and higher median weekly earnings. Okay. There are exceptions. It doesn't account for what you actually studied. It doesn't account for what degree you actually earned. Like some fields require a college degree, but they don't actually earn as much money as other fields that may not. Okay. Now you can make a lot of money in sales, all right, and get your college degree and go into sales. All right, but you're not. I mean, teachers, let's be real, are not going to make a money that's someone that's extremely successful in sales. All right, or maybe not, or social workers or things like that. Nurses and have degrees, and nurses may not make as much money as someone that is in sales, that is very successful in sales, or tech sales or something like that. I have some friends, that they're doing very well for themselves. I'm very happy for them. But they went to 4 years of college, and I've gotten my master's. It's just sometimes it doesn't always correlate. All right. That's a little rant for you. Happy New Year. Here we go. Let's keep going. So I kind of just gave my in general. I kind of gave my explanation that long-winded. More education you have, more money you make. And lower risk of unemployment. Even the unemployment part of it is not always true, because people lose their jobs, no matter what the degree, what their degree is. Okay, it is part of life. All right, we're going to pause there, and we will pick up with part C as a class. All right, we'll see you there.